But now to our initial block of 5 speakers. They're going to be speaking about IoT and shared data. First up, we've got Sammy Meyer, CMO of Deon Digital. Sammy.
Hello, everybody. First of all, thanks a lot for having me. Thanks to Elliot. Thanks to the Crypto Valley Conference. Thanks to all of you for taking your time and being here, discussing about the future of a very interesting technology. Maybe a quick word about me. My name, you've already heard, is Sammy Meyer. I'm the Chief Marketing Officer at Deon Digital, a young Swiss startup with subsidiaries in Switzerland, Germany, and Denmark. And what we produce is basically a tool set that allows to build applications based on distributed ledger technology in a fundamentally new way. Why is what I'm going to present relevant for you? Well, we want to make this tool set available to as many people as possible, and we truly believe this can be something radically new that you all can hopefully employ in the future. I'm sure there has been sufficient coverage about blockchain, distributed ledger technology, and when talking about this technology, I always like to cite The Economist, who once said in an article a few years ago, it's about as sexy as the double accounting standard that was invented sometimes in the 16th century. I'm not precisely sure about the figure. However, it's a fundamental shift. And this fundamental shift has dramatic implications on how people do business together. It basically represents a beautiful new internet of transactions, meaning it helps us to do transactions in a safe and decentral way, and thus eliminating intermediaries in a really great way, and thus really greatly helping to improve productivity. However, we as a company were asking ourselves, is it now sufficient to have a new layer of distributed ledger technology that brings together the different parties of a business transaction on the same platform, or is something more required in order to have them operate and do business together? And as the current chart implies, well, we came to the conclusion, yes, there is indeed more needed. What is actually needed is a common language for people to talk in order to establish, set up, and execute human agreements, contracts, or even processes within a company. And that's what our company is about. That's what our technology is about, which was developed mainly in Copenhagen by a team of Professor Fritz Henglein and his team. And what we are basically now doing is a technology transfer to bring this to you and hopefully to the world in order to make it usable for people. When we got started, I being Swiss and being born and raised in Zurich, I traveled extensively during my career, but otherwise I was really, I'm Swiss. I could have bet that our first client would be some sort of financial service institution. Well, the typical classical bias that I had there. However, we very quickly discovered that there was a large German conglomerate called Daimler that had precisely a problem that we could solve with our technology. What Daimler has realized is that the future will be connected mobility, and they realize that if they do nothing, they will probably become a contributor of hardware behind some booking platform aggregator, let's call it mobilitybooking.com of the future, and they will basically be a price taker. And due to that fact, basically, they discovered that they need to act, and the best way for them to act in order to counter such threats to their business model would be to establish an open consortium of people that build a connected mobility platform together. And instead of now talking myself too much, I would actually like to have Daimler quickly speak in a corresponding video.
Our world is changing. Megacities are rapidly growing, up to 53% by 2025. By 2030, 60% of the world's population will live in dense urban areas, challenging the way we live, commute, and travel. Consumers demand seamless mobility that suits their lifestyle. Sharing is the new owning. Access is the new product. Hannah is ready to commute to work. Her mobility contract gives her access to multiple options. In the future, we expect mobility to be a holistic and connected service. Based on her needs, the right service is chosen. Hannah needs to prepare for a meeting, so she is taking a pool car. An intelligent system controls the carpool based on traffic, availability, and location. An autonomous, driverless vehicle enables distraction-free working, even on the go. Cars, objects, and services communicate with one another. 30 billion devices will be connected by 2030. Induction technology charges the car on the road. On arrival, a micropayment is automatically transferred to the car. The vision is beautiful, but it currently requires a complex network of businesses, services, and transactions. The current state is inefficient and full of friction, making it difficult to collaborate. The entry barrier for new businesses is high due to legacy issues, efforts, and costs. Introducing the Mobility Operating System. An open, collaborative standard digital environment created for mobility services running on the blockchain. The model environment is based on a domain-specific language, reducing the complexity of developing new applications. Improving stability through automated tests and validation. The API provides easy access to services and smart contracts. The API also lowers entry barriers and facilitates collaboration. A distributed ledger acts as a safe authority that enables users to reclaim their data and personalize their offering. Hannah's car could be charged automatically because a contract agreement was already in place. With each new service provider, the complexity grows. To create seamless experiences, we need to collaborate. The future of mobility demands standards and collaboration. MOS is the only technology specifically developed for our future mobility. We want you to join us. To define, to design, to decide. Our vision: to create an open consortium. Let's define the future of mobility together.
So, to quickly elaborate how this works in a practical example, something that we're actively now building together with Daimler, Achmea, and other partners, let's quickly compare the old world to the new world. How would you build such a system in a traditional IT environment? Well, you would basically more or less have a classical V approach. Maybe you would say you have an agile project approach, but it would ultimately come back to the same. You would basically define top-down what is the functionality that is required. You would then at some point write specifications for that functionality, basically the use cases of your mobility platform. You would have to agree with the lawyers whether those use cases are the right ones. You would then talk to the technicians to make it happen. Things would be implemented, aggregated, built, and that's what Daimler actually did. However, somewhere along the process, they started that about 10 years ago, somewhere along the process they just got stuck. Things got too complex. Why did things get too complex? Well, you see the chart on your left. It's just dramatically difficult to combine all these silos into one ecosystem of offerings. What's the new approach, the new world on the right side? The new world is, imagine you have the distributed ledger platform as a persistence layer, basically the data layer, one single source of truth. On top of that persistence layer, you run an operating system which allows all the parties, independent of each other, to define contract templates, process templates, so to say. A process template in this context could be SBB putting a train ticket template onto the platform that others can then instantiate and purchase. Lufthansa might add its airline ticket as a template that others can go instantiate and therefore buy. Daimler would put its rental car as a template on the platform so that people can get a rental car, and the insurance Achmea would would put a template for a travel insurance to wrap the whole thing on the platform so that people can actually get a travel insurance, which is required by law due to regulatory standards in the European Union. What then happens is when the user comes to the platform and asks for the ticket to go from Zurich to Berlin, somewhere in the vicinity, and needs a rental car, and basically needs this whole ticket, not only can he get the itinerary as he could get over Google Maps as well, but he would actually be able to get the entire ticket from one platform and not having to log in with different providers, but basically via a B2B platform. This contract would be aggregated based on the corresponding templates, would be put in a master contract, which is basically an aggregated tree of all the subcontracts, and that's what he would get back as a ticket for the whole trip. How does this work? Well, basically, it starts with realizing that with the distributed ledger technology, we have a new hardware. And as very often when new hardware arrives, you soon after see the emergence of logical layers on top of that hardware. You have all observed this with your computers. You have your Dell, HP, or ThinkPad computer. It runs with a Windows operating system, abstraction of layer. You don't care anymore about the hardware. You use the operating system. Within that operating system, you might be using Word to write a letter. Again, you don't care about the operating system anymore because you're a Word user. Somebody could actually open Word for you. You would never have to care even about whether your Windows system or Linux system works properly. The same thing happened to phones, the same thing happened to internet, and is now happening to distributed ledger technology. What we speak about is an operating system to create contract templates that can then be combined with APIs to front ends, sensors, machines, tag scanners, anything in the physical world, and that allows people to define contract or process templates that can then be executed on the underlying distributed ledger infrastructure. So what our company does is it provides the corresponding adapters to the most relevant distributed ledger technology. Currently, by the way, we work mostly with Corda, which is not the fully public standard, but it's on the contrary, it's ready to be used. It has privacy, it has sufficient capacity for transactions, and so on and so on. And on top of this distributed ledger hardware, to which you become agnostic, as mentioned before, you now have an environment that allows you not only to script processes, first a payment, then a delivery, but also to script reports, go to the ledger and check whether a payment was done, and if yes, then do something. And it also allows you to script automated components. As an example, go to the ledger, check whether a payment was done. If the payment was done, automatically conduct the corresponding delivery thereafter at the latest possible date because you want to optimize your working capital, for example. And what you basically have is a technology that allows you to build applications in a more decentralized way and in a much more agile way. How does this work in more detail? Basically, our technology, and that was the work that was done by Fritz Henglein and the team in Copenhagen in a time period of over 10 years, is that what they discovered is that the basics of contracts, human agreements, and processes always evolve around the same, and that can be called deontic logic. It actually evolves around obligations, permissions, and prohibitions. You can do something, you must do something, or you mustn't do something. And yes, there is boilerplate language, yes, there is definition of parties, and yes, there is plenty of other legal stuff, but the basics of any human agreement is always around that. And it's actually a sequence of such statements. And what the team has done, it has basically first captured such logic in mathematics, because such logic can be represented by mathematical functions. And it then went ahead and translated this mathematics into code and into a language. And what results is a technology that allows you to script workflows, processes, contracts in a language that can be understood by humans, because yes, you just phrase your obligations, permissions, prohibitions, but it can also be interpreted by the computer, who then basically knows what your contract is about, what your agreement is about. It knows what can happen, but it also knows what can't happen. It basically does what any good contract does. It gives you the boundaries of action. It tells you what can happen versus what shall not happen. However, how you then navigate within these boundaries is still subject to the user, or basically can even be your business secrecy, because maybe you don't want to tell people how precisely you do that delivery, or when you do it, or how you do your production. But the contract just specifies you need to deliver up to some date. That's our principal distinction between the term smart contract, that you all know and are aware of, a piece of code that executes and can be seen as a contract, and our contracts, which we rather call digital contracts. Again, it gives the boundaries, but not the execution strategy. Let's look at an example, and sorry that this is so small, I'm aware this is not ideal for large audiences. But basically, let me quickly read it to you. This is out of our interface, which allows directly online to script such templates, which can then be instantiated and executed directly on a distributed ledger. Let me quickly take you through the example. First, you use the language to specify your contractual agreement. This is a very simple example, but I think it shows what you can do. It basically says Alice, which is the instantiation of a party 1, does a payment P where P price is 100, P receiver is party 2, or in this case Bob, and P timestamp is some date. And then this second party, in this case Bob, does a delivery where the delivery D, the item, is a bike that he needs to deliver, the receiver is Alice, and the due date is the original date plus some time lapse that you have agreed in the contract. What the technology then does, and that's really the secret sauce, it is able to translate from the left to the right. It basically creates automatically what any good lawyer would do as a first step. It creates the tree of all potential future contract states. So the system, based on only 12 lines of code, which would, by the way, be roughly 5 to 7 pages of JavaScript if you had to code this, the system directly can derive from these 12 lines which future contract states can happen and which cannot happen, because actually only the states that are represented in the tree can actually happen. So on the right side, left side from your perspective, there is all potential situations around the payment, and you read the contract tree always from left to right, and on the right side you basically have all the potential situations that may arise around the delivery. So delivery late, delivery incorrect, and so on and so on. That is directly derived from 12 lines of natural, almost natural language. And what then happens is that the system knows, and that you see at the bottom, the system knows which action needs to happen in the next step. It knows I'm now expecting for this given contract that was executed between Alice and Bob, I'm now waiting for a payment of 100. And it would reject any other action until this right payment does happen. And when that right payment does happen, one part of the tree would fall away and the residual tree would again be saved on the distributed ledger, so published to all relevant parties, and all relevant parties would again know what does need to happen next. So what, you may say? Well, the implications of this are actually quite dramatic if you think it through. The point being that you can suddenly implement business logic in a system that is dramatically more connective than traditional siloed architectures due to the distributed ledger architecture. You can suddenly write business logic in a way that is far quicker and far more agile than with any other programming technology. You basically don't have to be a technician anymore to do that. We have people in our team that never studied IT, that have a degree in economics, that basically now use our language in order to script applications. And all you need to add to these applications is a front end or some other connected sensors that actually records events into the ledger that then drive forward these corresponding contracts. And what you have is a far more agile way to program applications that then run on a decentral infrastructure. However, the infrastructure could actually even be a central one, being just the database in case, but it best runs on distributed ledger infrastructure. And so you have a dramatic increase in agility. You obviously have a dramatic increase in cost effectiveness because you basically, your business can start writing its own application templates that then can very quickly be brought to market. And it's ultimately also more secure because since you always know the system is deterministic, you always know which potential future states may occur due to the tree. And therefore, when you test your system, you actually no longer have to do test cases and hope that you got the right test cases and hope that there is no case that you did not foresee. No, the computer can actually go through the tree that I mentioned before and check all potential situations and then give you a feedback whether this is okay or whether you did forget something or whether there is any contract situation that would actually bring you to bankruptcy in the worst case. There is actually a second implication of this that is not even yet on the slide. Imagine your company being nothing else fundamentally than the sum of its contractual agreements. So your company has employee contracts, your company has provider contracts, your company has client contracts, financial contracts, and so on, but it's a sum of your contractual agreements. Every single contractual agreement will in the future be modeled in a tree that I showed you before, which is directly derived from the writing of the corresponding contract. What you suddenly have is a system that can actually project and do a simulation of all potential future states of that company. Very directly, no need to build a separate risk system, risk model, which we all do today when we have a core system and then we need a risk system that is basically a representation, a model of your core system, which is already a model of reality, so two derivatives. You will be able to do that directly out of your core system. Now, applications are very widespread. I talked about the mobility system that we are building together with Daimler and Achmea, but imagine to how many other situations such technology could be relevant. We're currently building with a Spanish bank a real estate one-stop shop, where you basically go to your bank and you want to get a real estate loan, mortgage, and not only that you can get that, but you can also get directly the registry with the public register. You can at the same time procure your gas and electricity for your house, and you can even buy other services all over a very similar platform than mentioned before. Imagine how this can be applied in logistics. Commodity trading, where very often today the delivery of goods actually takes place the delivery of goods takes place before the papering is done. And then the ship cannot be unloaded. So imagine you bring those parties on the same platform, everybody can do his own contract templates, and in the execution, it's just a matter of aggregating the right contracts together, executing them, and you basically have your delivery or commodity delivery papering. Let me go back to my initial promise. Why is this relevant for you? So we currently work mostly with large corporates, as mentioned, commodity companies, logistics companies, financial services companies, mobility companies, in order to develop our language and to get real-life requirements on the technology. However, we are fully aware that that won't really scale, and that won't really help us to define a new de facto standard around the technology we believe is a factor 10 more efficient than any other comparable technology currently out there. And we all know ultimately it's about de facto standards, not having the best technology. So what we intend to do soon is to open source a large part of our language so that basically you all can start to play around with it. Partners can start using the technology to do consulting projects with our technology, and so on and so on. And I hope I was able to encourage you to follow us, to follow this interesting development in technology, and please let me know if you have any questions. Thank you.